As Luke has mentioned, I just started my junior researcher position here. So during the next 6 years, I'm due to work mostly with Madagascar and Madeira. I've been working, well, actually I have this in the talk. So you already know who I am, where like I'm from Madeira. I've been working over the last 2 years, mostly with bats in Madeira. Yeah, you're gonna hear a bit about the work by Andre as well there. As I said, Madeira wanted to work here when I was a kid, but then I went to the tropics and opened this Pandora box of tropical ecology. One of the first visits to the tropics was to São Tomé and Príncipe. I did not overlap with my team, but almost. So I was working there, minor project for my master thesis with bird communities. This just to say that although I work mostly with bats, it's like I've been working with multiple taxa throughout the years. The first project that I did with Madagascar, it related with the effectiveness of protected areas. So basically, I was quantifying deforestation across the island and looking at the impacts of protected areas of different kinds. Then I visited Madagascar in 2010, part of a field course of the University of Helsinki. And there, I basically replicated my master thesis. And looked at, I compared bird communities in a tropical rainforest and agricultural landscapes. And just after this visit to Madagascar, I started working with bats. This is where I met Luke Powell. So this is in the central Amazon. Hopefully, this will be the topic of a different talk. This was where me and Luke were assessing the effects of fragmentation on different groups. If you're wondering, Filippo Palmeri was working at a few kilometers away in her system, looking at very similar questions at exactly the same time. But yeah, this was my PhD, and this is where the bat work started. The interesting thing here, well, the thing that matters for the sake of today's talk, is that during my PhD, I was invited by one of my supervisors to go to Madagascar and to speak with the students about bats there. So the place where we work in Madagascar is called Hanomafana National Park, and it's here in the tropical belt. So here, I don't know if you know much about the biogeography of Madagascar, but this eastern part here of the island is humid tropical forest. Here you have dry forest in the south, with lots of endemic species, with the spiny forest and so on. Here you have the majestic baobabs, that it's the dry forest. Here you have the highland, that is a bit of savanna. But anyway, like all of this, well, what's left of it is humid tropical forest that looks a bit like this. And in this area, in Hanomafana National Park, there has been a lot of research with lemurs. So this is where they have the famous golden bamboo lemur, and well, it's kind of endemic to this area. There has been a lot of work with reptiles and so on, some work with birds, but we knew, or up to this stage, almost nothing was known about the bat communities. This is how it looks inside of the protected area. This is how it looks in the outside of the protected area. So this is quite traditional from the humid tropics, especially in the paleotropics. So here you can see, well, slash and burn agriculture. So communities in Madagascar, they very much depend on rice. So they would eat rice for breakfast, lunch, dinner, you name it. So this is one way that rice is cultivated. This is called tabi, and it's basically you burn whatever forest is there. It might either regrowth or, well, most of the times it's regrowth in these areas. But yeah, main point is that around this protected area, there's around 150 villages here. So quite a large human population living in the agricultural matrix, mostly of two ethnic groups. I'm going to be speaking about some work that we did in ethnobiology a bit ahead, and this is relevant for that. But as you zoom out, so this is the exact same place as you can see here, this area that is burned, it's here. As we zoom out, one can see how the landscape is dominated by rice. So the tiny house that we saw in the previous pictures, you know, the batteries of this might die at some point. It's just there. And when we made this visit in 2013, we were having this environmental education project in which we matched schools in Finland with schools in Madagascar. And we were going around and speaking with the professors, exchanging drawings between the students and so on. And the idea of this project with bats that I'm going to be speaking about came from one of these visits to the schools. So we visited a couple of schools like this. And as we entered the schools, we were noticing the very intense smell of guano. And then speaking with the professors, they were saying that they had bat colonies inside of the schools. Prior to starting the classes, they had to swipe their desks because of the bat feces. So we, together with my supervisor at the time, Marta Bessa, we started thinking, like, we knew that in Madagascar there's around 50 species of bats, 80% of which are endemics. This photo here is of an endemic species of bat that only exists in Madagascar. And from my research and from, well, what we know about the effects of deforestation and fragmentation, we know that human influence in the landscape influences bat communities. These roosts, this artificial roosts, these buildings that were being used by the bats were also influencing the bat communities. So there was human influence on bats, but at the same time, bats were potentially like interacting with people through other pathways. So these feces that were present in the schools, they could present a risk of disease, zoonotic disease spillover, for instance. We know that in Madagascar, bushmeat hunting is quite intensive, at least of bats. Bat consumption is quite high. This photo was taken in the market there. So they are also important in terms of the food security. And so there was multiple pathways of the interaction between bats and humans. At the time in 2013, my colleague in my PhD, Adrià Lopez Balcells, told me about this project that they were doing in Catalonia, in which they were trying to assess the relevance of bats for ecosystem services in rice fields. And they had quantified how much the bats were helping the farmers in a very elegant study that was published in 2015. So potentially bats were being helpful for farmers in terms of increasing their agricultural yields. And in Madagascar, one of the largest companies is called Guano. So guano is very much used as a fertilizer there. So we knew that people and bats were interacting. There were multiple pathways of interaction. So we came up with this project that we wanted to look at how the landscape was influencing the bats, how bats were using the different roosts across the landscape. So this bit here, I cannot point, of the bats. When it comes to humans, we wanted to know about the human component of bat conservation, looking at perceptions, attitudes, knowledge of bat communities, and so on. Then we wanted to see the interaction between through food security, both in terms of potential increases in agricultural yields, but also bushmeat consumption, and how guano was being used as a fertilizer, if it was indeed boosting productivity or not. And we're also interested in terms of something that is very topical right now, zoonotic disease spillover. We were collaborating with the Department of Virology from the University of Helsinki. So we were collecting samples to assess viruses. And now I'm going to be, during the next section of the talk, I'm going to be speaking mostly about two papers that we published, one looking at roost selection and the other one looking at potential agricultural services that the bats might be providing in Madagascar. So 2015, 2 years after thinking about this project, we returned to Madagascar. And one of the first things that we did, we sampled 10 villages. And in those 10 villages, we sampled 180 buildings. So we knew that bats were using buildings such as schools, but we wanted to know in which other buildings they were present and which were the features of the buildings that were relevant for bats. So we sampled everything that we could, everything from private houses to schools, churches, even public toilets, markets, across the board. At each of these places, we collected around 17 variables, building heights, type of construction material, the type of the roof material, the number of people that were using the place, if it was a public building or private, if the house had cats or not, multiple variables. And parallel to this, we were sampling the bats in a wider diversity of as much buildings as we could. So here, this photo, my colleague James, we are just sampling a school. This is a school patio that you see here. Here, this is a city council. So this is the mayor house that is there in the background. This one had a colony of bats of several hundred bats. This is a village here with private houses and so on, and we captured tons of bats. Like there was this. I think this was the night that we captured more than 100 bats. So we discovered that out of the 180 buildings that we surveyed, 21 had bat colonies. Some of those bat colonies we estimated to have more than 1,000 individuals. This was basically of 6 species. The most common ones were the molluskids that here in Portugal are represented by one species, that is Tadarida, that Vanessa and Francisco Amorim and Nugo have been working for quite a while. 2 species of Vespertilian bats and 1 species of InBIO noris, that is a family that we don't have here in Europe. Oopsie daisy. This is just an example of the sort of results that we got. When it came to wall types, so here on the, this is on your left, no bats, on the right, bats. You can see that buildings with brick and with cement, the chances is that you would find a bat colony. If the roof material was metal, the chances were that you would find a bat colony. If the chances, if the building is public, the chances is that you might find a bat colony as well. So if we look at the buildings like this, like the building above, like the school, has cement walls, a metal roof, is public, is likely to have a bat colony, and the one below is, well, the chances is that is not having a bat colony. This is quite relevant because now we're seeing a shift in the type of construction that you come across in humanized landscapes, and we're seeing more and more modern buildings. So as the type of construction goes for the more traditional buildings to the newer types, the chances are that you're going to have a higher chances of increase of interaction between humans and bats. And this is true for Madagascar, it's potentially true to other tropical landscapes. So we were doing this during the night, we were sampling the bats, and the Malagasy team, well, we were sampling the bats in the houses, but parallel to this, we scattered bat detectors throughout the landscape. We had 55 sites throughout the main habitat types in which we sample bats. The habitat types that we were sampling were basically secondary vegetation. Here you can see regrowth, this forest fragment that normally are at the hilltops, the dry rice that you can see there, that is the tavi, the areas of slash and burn agriculture, and the irrigated rice that you can see here up front. And also we have places inside the park in continuous forest. So we had the detectors going on during the night, but during the day we were going into the forest, sampling bats in as wider diversity of habitats that we could. So in the tropics, places with water points are especially good for capturing a wider diversity of bats. That was a waterfall inside of the protected area. Here we're scrapping nest nets across the river. Here it's a stream next to a village, and we were doing this so that we could get the echolocation of the bats, so we could match what we were getting in the automatic detectors with the bats. That's here we're doing a releasing call. So my colleague Adrien is releasing the bats. I was in front recording with a detector. And in this specific study, we got more than, well, that 9,000 bat passes of 11 different sonotypes. And here I say sonotypes because for some species, we're able to match a given echolocation type with a species, but for the other, the echolocation of multiple species was so similar that we had to cluster them. But fast forwarding to the results, this is one of the only
Não, eu joguei que estava, eu devia estar a ver isto.
One of the only graphs that I'm going to present. So here what you have is mean bat passes in the different habitat types for the different sonotypes. In pink, you can see this dry rice, this hillside rice, and the first plots is with molosids. So these are the free-tailed bats that in Europe we have the Tadarida. And what we can see from this graph, the take-home message is that the activity of bats that correlates with feeding activity, and I can tell you later how we know that it's feeding activity, was 11 times greater in dry rice than it was in forest for this type of bat. For Vespertilians, that it's the most species-rich family of bats. So this MI is Minneopolis. For these two types of bats, the feeding activity was 7 times higher in irrigated rice than it is in forest. So what this says is that at least for the most common groups of bats, they were favoring the agricultural rice fields for feeding. While we were doing this, we were also sampling insects. We had insect traps throughout the landscape. We were speaking with the farmers to get to know which were the main agricultural pests. And we collected fecal samples from quite a few bats. So we had 150 fecal samples that we collected. And from those, we use metadNA barcoding to assess the identity of the prey of 56 fecal samples from the 6 more common species. And this, I'm very aware that this is a very minute sample size, but nonetheless, it was able for us to identify multiple agricultural pests. That was what we kind of wanted with this quite short-term study. One of the main agricultural pests that we came across was this antworm. That is an important rice pest, and that in the late 60s was found to be responsible for a decline in 1/5 of the rice production in Borneo. And when we are speaking in communities that depend so much on rice, this is quite important. We also find other rice pests, and interestingly, we find not only other agricultural pests from citrines and sugarcane and so on, but we came across important human disease vectors, including Anopheles mosquitoes that were being preyed by bats. And these are vectors of malaria. And this Culex, it's a vector of Japanese encephalitis. And if you're not familiar with Japanese encephalitis, it's a sort of things that if it does not kill you, it can leave you in bed for the rest of your days. So it's quite serious. And they're also, we also found that they were preying on black flies that are responsible for the second most common case of blindness due to infections. So now I'm going to be speaking about something that is not very much within my comfort zone. So this is a study that we did. This one was in 2016, I think. So after doing this initial work with mostly ecology, we returned to Madagascar, and this time we wanted to look at the human component. So we knew that throughout the landscape, there was at least 14 different species of bats. And in my lab in Finland, we are very lucky to have Álvaro Fernandes Lamazares, that it's a very close friend that works in ethnobiology. And so together with him and a few others, we set a study to try to understand the knowledge, the attitudes, and the perceptions towards bats in this landscape. So we did more than 100 surveys with open and close-ended questions. And this was part of a special issue that we published early this year. devoted to the ethnobiology of bats. So just to give you an idea of the demographics of the people that we surveyed, we had a 50-50 sex ratio of the respondents. Most respondents were from the main group, ethnic group, the Stanala, and the age of the most respondents was between 30 and 60. All that we do in Madagascar is in very close collaboration with the local collaborators. Here you can see two of our friends and colleagues, and they were especially important for this study because they were the ones translating the questions, interacting with the locals. So we were going house to house, speaking with people. And one of the first questions is, are you aware of bats in your village or in the surroundings of your village? More than 90% of the respondents say that they were aware of bats. 50% mentioned there was one type of bat, 40% two types of bats, and around 80% two or more types of bats. And the main types of bats that people referred to were either Kananavi or Kentopi, that they described as being small, black, and mouse-like. This was 80% of the respondents. And 30% of the respondents also mentioned this Angavo and Fanihi, that they described as larger, that Kananavi, lighter and cooler, and they said that they eat fruits. Oopsie daisy. So this one's the Kananavi. They are mostly the molluscid bats, at least what we get from the description of people. Whereas the Angavo are mostly the frugivorous bats, the flying foxes. For me, one of the key take-home messages of this study relates to this. So we found that 60% of the respondents of the age group above 60 knew about frugivorous bats, so the flying foxes and so on. Whereas fewer than 20% of the respondents with less than 30 years knew about these bats. And what I get from this is that the frequency of encounter with frugivorous bats is decreasing, and with that they're getting eroded from the collective memory of the locals. And this is a phenomena that is well known in the literature as shifting baseline syndrome. And I assume that this relates with hunting of these bats. So I've never seen one of these bats there. Like, I know that my colleagues have captured them after we finished the time that we were there, they continued nest netting, and they sent photos. The locals, they say that they see it once in a while, but nonetheless, the frequency of encounter seems to be decreasing. And I assume that is due to hunting, because we know that there's some serious hunting going on. So we asked what was preying on bats, very basic question. More than 20% of the respondents said birds. This is interesting per se, but one of the most interesting things is that 14% mentioned dogs. That was quite surprising, and 3% mentioned cats. Cats we expected, and we already knew from our roost selection study that locals even use cats to displace bats from their houses. So they just put a cat on the roof, and it kind of takes care of the colony. But dogs were quite a surprise. And after speaking with after speaking with the locals, basically they said that the kids, they get bats to play with the bats, and once they finish playing with the bats, they dispose the bat, and the dogs go capture the bat and end up eating. And you can see here that this is not a well-fed dog. So if they see a food opportunity, they would probably go for it. But when it comes to cats, I think that this is very interesting now in the age of COVID, and when we're speaking so much about zoonotic disease spillover, is how humans interact with bats and zoonotic diseases from bats, we don't need to think about Madagascar right now. We can think about ourselves. We don't interact much directly with bats, but if you have a cat and your cat is going outdoors, the cat potentially is interacting either with bats or rodents that are important zoonotic disease hosts, and then you're petting the cat. So there's a direct link right there. And there's a paper that was published this year that debates this sort of dynamics. So this just emphasizes that this sort of dynamics is also happening in the tropics, and it's something to keep an eye for. So more than 20% of the respondents mentioned that they have used bat guano as a fertilizer. 13% had consumed bats. 4% had sold bat meat, and at least 2% had used bats for medicinal purposes. These percentages here are very similar to what we found in a different study that we had already done in South Madagascar in the dry forest. So very, very similar percentages. Here we're actually looking at taboos relating with the use of caves and so on. 60% of the locals described bats as being good. They mentioned benefits such as consumption of mosquitoes, and most of them spoke about guano. Guano was very, very important for them. 12% mentioned bats to be dangerous, and even back then, this was 2016, they mentioned the risk of zoonotic disease spillover. But also they complain about the smell of the guano in the buildings and damage that bats might cause to the buildings. Something that is very strong in Madagascar is the fadi. So these are cultural taboos. So 25% of the respondents were aware of or knew of fadi that related with bats, so taboos that related with bats. One of the interesting things is that very often people would relate the taboos relating with bats with rodent-related taboos. So they would say something like, bats are rats with wings, and it's a taboo to eat rats, so it's also a taboo to eat bats. So they kind of got this taboos by association, apparently. 25% were aware of myths and legends and folk tales. This was really, really interesting, an interesting aspect. Just to tell you a very popular one, this almost everybody that knew about legends that related with bats, folklore knew about this story. So in Madagascar, there's so fire is very present within their culture. So it's a way of farming the land and so on. So there was this story about, and also this is one of the most common birds, like the drongo that you would see in agricultural landscape. This is a drongo coronatus. As you can see, it has this feather on the head. But basically the story goes that there was a big fire, and in the beginning, bats were birds, and bats had feathers, and they would behave like the other birds and so on. But when this big fire happened in the forest, all the birds went in to try to put it out. And the birds worked during the day and tried putting it out, but then they were really tired. They went to sleep, and the bats stayed up all night trying to fight the fire. And eventually they went really close to the fire. They were beating their wings. And with that, they managed to put the fire down. But in the process, they burned their feathers. So that's why the bats don't have feathers nowadays. But then God appeared and he said, like, yeah, who put down the fire? And whoever put down the fire is going to be the king of the forest. So this drongo that is really smart and was awake at the time because the bat was so tired that he went to sleep during the day. This drongo went to God and said, I put down the fire, I should be the king. And he was crowned the king. But then the bat woke up and he said, no, I was the one putting out the fire. I should be the king. And God said, no, it was a drongo. Drongo is now the king. And basically the bat replied, okay, so if you don't believe me, I don't respect you anymore. And from now onwards, I'm going to sleep with my ass up so that you can look at my ass all the time. So that's why the bats sleep with their heads down. This is a very popular story there, and there's multiple variants of this story. It's really funny. Well, you can read about this in the paper. This is the supplementary materials with this. Take-home messages. Well, from the first study, we know that there's a systematic preference of bats in Madagascar for public buildings, but these more modern buildings made out of cement and metal roofs and so on. We know that this sort of buildings are increasing in Madagascar, so the chances are that the amount of human-bat interactions are going to increase in the future. And this makes it especially important for us to try to understand how we can try to maximize the benefits of having bats in the landscape, either due to their agricultural services due to pest suppression, or others, like even thinking about bushmeat and so on. And of course, bat conservation, but try to minimize this interaction with this in close quarters with humans. And this might, one option might be to try to scatter bat boxes throughout the rice fields to try to get the ecosystem service in terms of the rice. And but there's a bot here that I'm going to approach here. But this is some research that we want to do now in the coming years. When we speak about this, the paper about ecosystem services that we published, we speak about potential ecosystem services because we haven't yet quantified. We know that bats prey upon important rice pests, for instance. We don't know if there's increased rice yields due to this. So there's quite a lot of research that needs to be done there. So I did not speak much about this, but we know that different types of bats can be found in different areas of the landscape. So there's a couple of species that are very sensitive to deforestation and habitat fragmentation and can only be found in primary rainforest, whereas you have all the other species that are more generalist and can manage well within human landscapes and even appear to be benefited by human landscapes. So this kind of shows that if we want to preserve the wider diversity of bats, we need this heterogeneous landscape in which we still have primary forest. Well, this is well known from other places and from the fragmentation research, but yeah, we have the data. We haven't yet published the data looking at landscape ecology. We know that multiple species that prey upon important rice pests or important pest species are cave-dwelling species. And not only caves are used as the place where people extract guano, but also there's increasing levels of cave tourism. So we need better legislation to try to minimize the impacts on the colonies of bats, not even to speak about chances of zoonotic disease spillover due to people accessing these places with high bat numbers. And what's next for this? Of course, so I'm starting now my 6-year junior research grant that focuses mostly in species interactions, so interactions between different species of bats, predator-prey interactions, and so on, in both Madagascar and Madeira. So I'm going to be doing quite a bit of work in Madagascar, hopefully. For that, we have a large grant from the British Ecological Society that I'm due to start next year. We also have a large grant from the National Geographic, also to work, and there's more to try to quantify ecosystem services, probably doing exposure experiments and so on. This is in collaboration with the Finnish team, and in particular with Alia Lopez Baucels. And this is the place where we work. It's called ValBio Research Center. That is that quite fancy building that you can see over there. The country has been closed for most of the last 2 years due to the pandemic, but now one can restart the field work there. So soon we're going to be doing some more work. Parallel to this, just to advertise a project that me, Luke, Felipe, and a bunch of others here, Vanessa Mata, are collaborating. This is a project in Madagascar that looks at very similar dynamics to the ones that I presented between bats and rice production, but also includes birds. So we're going to be doing quite a bit of work in Guinea-Bissau in the coming years. And just as a final remark, when we're speaking about Madagascar and Guinea-Bissau and this sort of communities, we were speaking about people that live in the edge of poverty. So this lady here, I took this photo when we were doing field work, and what you can see in the purse there, well, you cannot not actually see, but she has a purse full of rice beans, and she has that stick that she walks, and she makes a hole in the ground. She puts some rice beans, she covers it, and that's basically her provisions to her family. So that's what she's hoping to get to eat for the coming months. And they basically depend on that for their livelihood. So if there's a chance that bats, birds are either in providing ecosystem services or the other face of the coin, if they are providing these services, like we need to quantify this, and we need to quantify this not only that we have a good message to spread to the media and try to help the animal communities, but we need to do this for the sake of the locals and even for our own sake. Yeah, so that was it. If you're interested about ethnobiology, we published, or we worked on this special issue in which we published single research from, like the one that that I mentioned from Madagascar, with studies from Indonesia, Cambodia. There's stuff from Sweden and such, Namibia. So if you're interested, please have a look. Very just in 2 minutes to say that in the last 2 years, I've been basically working with bats in Madeira, trying to look at similar questions to the ones in Madagascar. Madeira, we only have three species, but nonetheless, we've been working throughout the island. So this was work that was done in 2016. We used audio mods to sample 200 and such places throughout the island. This different colors relate to different habitats. But then a big fire happened in 2016, probably you remember from the news. This is how it looked on the satellite, so massive areas that were burned. And we had data that was collected either prior or just in the aftermath of the fires in 2016. So this year, together with RIM, that is also based here in CIBIO, we resampled all of these places 5 years down the line, and we're trying to assess the effects of fires in bad communities. Not only that, this is only one aspect that we can use this data set for. But yeah, I was just speaking with Ricardo that we have bird data with this audio mods that we were scattering throughout the landscape. Here with Andre and with Francisco, we're looking at the effects of climate change in the bats in Madeira using this data set that we collected in 2016, and potentially we're going to add more data to this. This photo was taken in Porto Santo when we were doing fieldwork, very similar to this one that I just described. We basically scattered audio mods throughout the island, and we were sitting there for a couple of days. Angelina here that you're going to be seeing in the corridors in CBO, she's working with me and Vanessa to try to assess try to investigate what bats are feeding upon in Madeira. So we have samples from all the 3 species throughout the island and so on. And here just a photo of other people that have been with me in Madeira over the last month, or are still in Madeira and working with birds and butterflies and cats and a bunch of different things. So there's if you're keen to do research in Madeira, I'm going to be based there for the coming months. You're all welcome. There's a place for you to stay and things to do. And yeah, and I've been told that the water temperature is 26 degrees right now. So. And yeah, big thanks to all my colleagues. Most of what I presented today was done parallel to the Amazonian work, but with my Finnish team, which is here. This is the global change and conservation team of Marca Bessa. The photos here, most are from Joan de la Maia, and it's a award-winning photographer, and award-winning is the wildlife photography of the year. So it's yeah, he knows what he does. Adria has been with me for the last 10 years working all over the place, and we're due to continue this work in Madagascar, and of course the Malagasy team that you can see there. And yeah, thank you very much. That was pretty much it.